In this video we're going to do angles. I'm going to just do it all in one big long video, I think. So angles, of course, are measured in degrees. Okay, so it's going to be some number and then degree. It is a unit. There are 360 degrees in a complete circle. At the end of year 12 and definitely in year 13 calculus, you'll be using a different set of units to measure angles, and that's radians. But before then, don't use radians. And maybe just to go over again what your calculator needs to have, it needs to be set up in degree mode. So go shift, set up, and here it's in radian mode. It needs to be in degree mode. If you have it in radian mode, it's just going to give you a gobbledygook answer. Okay. So all the way around is 360 degrees. So this means that angles coming from a point, let's call this point E, this angle here, and plus this angle here, plus this angle here, plus, oh, it's another one, yellow, this angle here, they add to 360 degrees. Okay, so if this was 74 degrees, what would these other ones be? Well, we can work out the other ones. So just let me wrap that out. So the reason we can work it out is that opposite angles are the same. This angle here, the orange angle and the yellow angle are the same. So that must be 74 degrees as well. So maybe we'll state the rule there is opposite angles are equal. So we know two other things. We know that all the way around it's 360 degrees. We know that this angle, the blue angle here, and the green angle here are opposite, so they must be equal as well. So what is left? Well, let's grab the calculator. We know it's 360 degrees all the way around. So let's take off 74 for the orange angle, take off another 74 for the yellow angle. So that means that the green angle and the blue angle here must add together to give us 212. But we know that they're the same, so if we divide it in two, we're going to find that this angle here must be 106 degrees, and this angle here must be 106 degrees. So maybe this is rule 1. Rule 2 is that angles on a full circle add to 360 degrees. Okay, the third rule, notice that this angle here and this angle here, they're on a straight line. The line is AB. Angles on a straight line add to 180. So the blue one here and the orange one add to 180, and 108 plus 74. Calculate if you want. 106 plus 74 comes to 180. Notice as well, this angle and this angle add to 180, this angle and this angle add to 180, and this angle and this angle add to 180, because this is also a straight line. So a third rule of angles is angles on a straight line add to 180 degrees. In this problem, we're going to apply those rules. So these are all straight lines, and I'm given B and E. B is 45, E is 60 degrees. What are A, D, and C? Well, C is going to be really easy because it's opposite E here. These lines, this line here and this line here, are common for both of them. So C must be 60 degrees. What is D? Well, D must be is on a straight line with C. This line here, I can highlight that. This line here is a straight line, so D and C must add to 180 degrees. So we know if C is 60 degrees, C plus D equals 180 degrees. I don't know what happened there. D equals 180 degrees, and C is 60 degrees. D must be equal to 120 degrees. Okay, now A, B, and E here are all on the same straight line. So E plus A plus B must also add up to 180 degrees. But we know that E and B are 60 degrees and 45 degrees. So E plus A plus B add to 180 degrees. We know that E is 60 degrees plus A, that's what we don't know, plus 45 degrees equals 180 degrees. So A must be equal to 180 minus 60 minus 45. And if we grab our calculator, we find that 180 minus 60 minus 45 comes to 75 degrees. So 75 degrees. Now what we want to do is we want to check to see that all of them add to 360 degrees, because they all have this common point here. They'll have this common point. So let's test it. 45 degrees plus 75 degrees, it's A, plus 60 degrees, that's E, plus 120 degrees, that's D, plus 60 degrees. Does it come to 360? Yep, sure enough. Maths works. We come to parallel lines and angles in parallel lines. The tests seem to be obsessed with these, and they are pretty important. So all of these lines are straight, and these lines are parallel to each other. That means parallel, this means same length. So corresponding angles really means that the same angles in a different location. So this angle is the same as this angle here. They're just in a different place. It's almost as if one is cut and pasted to the location of the other one. So what that tells us is that this angle here must be the same as this angle here. And this angle here must be the same as this angle here. So just to draw it. So this angle here must be the same as that angle there. Of course, these are opposite each other. So this angle here must be the same that one there, and must be the same as that one there. And these two here are going to be corresponding as well. And it also means that this angle here must be the same as this angle here. And these are opposites, so this angle here must be the same as that. And this one, this angle here, of course, is corresponding to this one here, so they must be the same as well. Alternate angles come from that same theory there. If these angles are the same, and this angle here is the same as this angle here because they're opposite, it must mean also that this angle here equals this angle here, because this angle here and this angle here are corresponding angles, and that is opposite, so they must be the same. So alternate angles would be following. So if this is an alternate angle there, it must be the same as this angle here. So in your test, if you were tested on this, you'll be asked to justify why this angle here is the same as this angle here. So if this was, say, 42 degrees, this must be 42 degrees, and you'd need to say that these are alternate angles. Give some justification. Right, so if those are alternate angles, then this and this must also be alternate angles. And we can work out what they would be because they're on a straight line. So the green angle here, let's call it theta. Theta is going to be equal to 180 minus 42, which is, I think, 138. The last type of angles that you'll be required to identify are co-interior angles. So co-interior angles are kind of angles that are inside a box. So if you kind of imagine that this is a sort of a box here, the angles inside that box, this angle here and this angle here are supplementary. So in this case, it doesn't mean that they are equal to each other. It just means that this angle here and this angle here add to 180 degrees. They're supplementary. Okay, so it would also mean that this angle here and this angle here would also add to 180 degrees. For some reason, my pen is suddenly being really huge, but they add to 180. So that's co-interior angles. So you would need to, if they give you this angle, they might ask what is this angle here if they give you this angle, and you'd need to do a little bit of algebra and state that they are co-interior angles, they add to 180 degrees, or that they're supplementary. Either one is okay. we've already come up against right angle triangles. So let's have a look at other types of triangles that you need to know about and need to be able to identify and dissect and label and name. So equilateral triangle here, all the sides are the same length, and all the angles are the same. Okay, and if all of the angles in a triangle and all triangles add up to 180 degrees, this theta and this theta and this theta are the same, so this theta there must be 180 degrees divided by 3 is 60 degrees. So far so good. Now, isosceles triangle, 2 of the angles and 2 of the sides are the same, and I'll do that in green. So 2 of the sides and 2 of the angles are the same. Again, all of the angles add up to 180 degrees. So if this is the same length, the 2 base angles here are going to be same. And let's call that theta. I need a nice Greek letter, so I'm going to call that theta. So this angle here is going to be 180 minus 2 theta. So the 2 angles that are the same are the 2 that are next to the 2 sides that are the same, and these are sometimes called the legs. Okay. The last type of triangle is the most common type of triangle, and it's kind of the mutt of triangles. It's a scalene triangle, so none of the sides are the same, and none of the angles are the same. Okay, so this angle here, this angle here, and this angle here are not going to be the same. A, B, C, not the same. They all add up to 180 degrees though, like all triangles. So A plus B plus C equals 180 degrees. That's that, really. Let's go from triangles, the most simple polygon, to slightly more complicated polygons. Hopefully this is just a recap and a revision of what you should already know. But it's worth looking at what exactly a polygon is. So a polygon has to have 2 sort of qualities that make it a polygon, and that is that all the sides are straight. Okay, so that is not a polygon. All of the sides must be straight. The second one is that the area must be enclosed. So there can't be any holes. So in other words, that would not be a polygon because there is this great big dirty hole here. So imagine that you're sort of looking down from a satellite at a swimming pool. If the water is leaking out of the swimming pool, it's not a polygon. So if you have a look, all of these are indeed polygons. All of the sides are straight and all of the sides meet each other. There is no funny business going on. There are no gaps. There's no holes. Okay. The interior angles of any polygon add up to a formula. So the internal angles add up to 180 times n minus 2, where n is the number of sides, or number of vertices really, but it's going to be the same. So any polygon has the same number of vertices as it has sides. So I've done a few here. This one is a 4-sided polygon, 5-sided, 6, 7, and 12. So the internal angles means this angle here, plus this angle here, plus this angle here, plus this angle here. They would all add to n minus 2 times 180, which is 4 minus 2 times 180, which is 360 degrees. Okay. For this one here, 5-sided, this angle plus this angle plus this angle plus this angle plus this angle must add up to, and let's work it out. So n is 5. So 5 minus 2 is 3. Hopefully you didn't need a calculator for that. Times 180 is 540 degrees. So all of these angles add up to 540 degrees. Just for completeness, let's do exactly the same thing for these other ones. 6 minus 2 is 4. 4 times 180 is 720 degrees. Uh, 7 minus 2 is 5. 5 times 180 is 900 degrees. And our monster here at the end, this 12-sided shape, 12 minus 2 is 10 times 180, you really shouldn't need a calculator for that either, to be honest, is 1800 degrees. So these are irregular polygons in that not all the sides and angles are the same. Okay, now we're going to do regular polygons. So here are some regular polygons. Here we have a 4-sided regular polygon, also known as a square. 4-sided, 5-sided, so a regular pentagon. 6-sided, a hexagon. 7-sided, a heptagon. And this is a 20-sided regular polygon. I can't remember what that one's on my head. I think it's dodecahedron. No, I can't remember. You can look it up. It's about to get into exterior angles of a polygon. I realize that I haven't gone over one very, very important point of a regular polygon. So here are two of the regular polygons that we had, the 5-sided and the 6-sided polygon. And we worked out that the total interior angles add to 540 degrees in this one. And 4 times 180 is 720 degrees in this one. So that means that each of these angles, because they're the same, all of the angles on the 6-sided polygon, if we divide that by 6, are going to be 120 degrees each. And in the 5-sided, it's going to be 540 divided by 5, so 108 degrees for each of these interior angles. All right, with that said, let's have a look at the exterior angles. And I'm often reminded of a Catherine wheel, which is a firework. And you'll see what I mean, because I'm going to put, if I can, a little video of one on splicing in now. Okay, so if we have the exterior angles, oh, and my program died on me there. The exterior angles, if we extend this side out and this side out and this side out and this side out and this side out, just like a Catherine wheel, all of the angles for all polygons, regardless of how many sides they have, always add to 360 degrees. Okay, so the exterior angles on this one, we extend this side out, we extend this side out, just like a Catherine wheel, just like the firework. These added up are also going to just add to 360 degrees. It's the same for any polygon, which is concave really, but any polygon that you will see this year, it has this property. The exterior angles, that is the Catherine wheel angles, add up to 360 degrees. Again, this should just be a recap for you. These are two similar triangles. What does it mean by similar? Similar means that the angles are the same. So that's 80 degrees and that's 60 degrees. That is going to be 40 degrees and it's going to be exactly the same, 80, 60, 40. The proportion of the sides is also going to be the same. So if this is 4 centimeters and this is 2 centimeters, and we're told that this is 5 centimeters, this is going to be half of that, so 2.5, because 4 divided by 2 is 2. So the enlargement factor is 2 in this case. And just because we can, let's say this side was 3, this side is going to be 1.5. I don't know if those are the exact numbers, but that is basically the theory of a similar polygon. We can use it to exploit things later on when we come to do the questions. And that's pretty much it for angles, so I'll call it a day there.